Here we're solving a probability problem involving dice. If we roll one die 5 times, what's the probability that you obtain exactly 2 4s? We're going to start by determining the total number of elements in our sample space. The total number of elements is going to be given by 6 to the 5th power, because each of the 5 rolls has 6 possible outcomes. So we get 6 times 6 times 6 times 6 times 6, which is 6 to the 5th power. And that equals 7,776. That's the total number of elements in our sample space. If we consider the rolls as a sequence of 5 slots, so we'll get some positions again, just to keep in mind what we're doing, then the number of ways to position 2 4s, because we're looking for 4s, the number of ways we can position those 2 4s in our 5 slots is going to be given by C 5, 2. So we have 5 slots, and we're going to choose 2 of those. C 5, 2 is equal to 5 factorial over 2 factorial times 3 factorial, which is going to equal 10. Next, we need to find the number of ways we can get the remaining 3 slots filled. We can fill those with any of the 5 remaining numbers. We don't want 4s, because we wanted exactly 2 4s. So there are 5 remaining numbers we can put in each of the 3 remaining slots. Since repetitions are allowed, that's going to be 5 times 5 times 5, or 5 cubed, which is 125. So there are 10 ways to position the 2 4s. There's 125 ways to position the remaining 3 numbers. To get the total number of ways we can get exactly 2 4s, we need to multiply these together. We get 10 times 125 is equal to 1,250. Now that's just the total number of ways that we can get exactly 2 4s. We have the total number of ways we can get results from rolling a die 5 times, so the probability of exactly 2 4s is equal to 1,250, it's the number of ways of getting 2 4s, divided by 7,776, which is the total number of ways we can roll a die 5 times, and we'll get that that's approximately equal to 0.1608.